Introduction. Aman, can you please come here? I want to ask you something. What happened today? See there. A machine is moving the scrap of iron and steel from the waste material. Yes, I can see that. But how is it possible to extract the desired material from the wastage? It is simple. Basically, it is an electromagnetic crane which works on the principle of magnetism. Its anchor is made up of an electromagnet. When electric current is passed through it, it behaves like a magnet and attracts only iron and steel from the scrap. Okay, I got the answer of my question, and I want to know more about this. Will you please tell me? Sure. Today we will study about the magnetism and matter.
Objectives.
At the end of this lesson, you'll be able to define magnetism and bar magnet, know about magnetic field lines, analyze bar magnet as an equivalent solenoid, analyze dipole in a uniform magnetic field, describe Gauss's law in magnetism, know about Earth's magnetism, define magnetization and magnetic intensity, understand magnetic properties of material, analyze hysteresis curve, describe permanent magnets and electromagnet. Definition. The phenomenon of attracting magnetic substances like iron, nickel, cobalt, etc. is called magnetism. A body possessing the property of magnetism is called magnet. The two centers of attraction in any magnet are called its poles and are named as North Pole and South Pole. The region around a magnet in which it exerts forces on other magnets and on objects made of iron is called a magnetic field. Bar magnet. A magnet in the form of a bar with magnetic poles at each end is known as a bar magnet. The main properties of a bar magnet are as follows. When a magnet is suspended freely, it aligns itself with one end pointing towards north of Earth and other towards south of Earth. Unlike poles attract and like poles repel each other. A magnet attracts magnetic materials. This attraction is maximum at the poles. Isolated magnetic pole does not exist. Magnetic poles always exist in pairs. A magnet can induce magnetism in substances like soft iron, cobalt, nickel, and various ferrous alloys. Magnetic field lines. A magnetic field can be represented by lines called the magnetic field lines. A magnetic field line is defined as the curve, the tangent to which at any point gives the direction of the magnetic field at that point. Magnetic field lines never intersect each other. The magnetic field is stronger in regions where the field lines are relatively close together and weaker where they are relatively far apart. Magnetic field lines are always closed continuous loops. Bar magnet as an equivalent solenoid. The magnetic field patterns are similar of solenoid and bar magnet. Also, the solenoid itself behaves as a bar magnet with the north pole on one side and the south pole on the other side. Two adjacent solenoids can be either attracted to or repelled from each other, depending on the relative directions of the currents. Let us consider a solenoid of length 2L and radius r composed of a series of n current loops, each carrying a current I. The magnitude of magnetic field at an axial point P due to this elemental loop is given by mu naught upon 4 pi multiplied by 2m upon r cube, when m is the magnetic moment of solenoid. This is exactly the same as that of a bar magnet at far off axial point. Assessment. Before proceeding further, let us know how much have you learned. Drag and drop the correct option.